If you believe the popular charts of yesteryear, 1 is the loneliest number. And it's true, there's strength in numbers. And NSX knows that, and that's why they created the NSX controller cluster. The controller cluster is a group of virtual machines that provide services for the benefit of logical switches deployed to our ESXi hosts. In this nugget, we're going to take a deeper dive and understand what exactly is the NSX controller cluster. So as we jump into understanding the NSX controller cluster, let me remind you of a little trick that I like to use in order to get more confident in understanding any technical term or acronym. And that's this simple idea: say it backwards. I know, it seems too easy. So what is the NSX controller cluster? It's a cluster. It's a group of multiple VMs that operates at the control plane in order to control what? In order to control NSX. So what if we glean from that? Well, this is going to be a core part of our software-defined networking that NSX is here to provide. Software-defined networking means we have decoupled the brain from the rest of the body. So that distributed switch that's going to be running on each and every ESXi host is going to simply forward frames according to the rules, according to the intelligence defined in the NSX controller cluster. So if we have a shared VXLAN between two VMs, is that frame going to go through the NSX controller cluster? Of course not. That's describing something that would happen at the data plane where we forward frames. But how does the switch know how to forward those frames when we're dealing with multiple ESXi hosts or VTEPs that need to be able to connect to each other? That's going to be intelligence that is provided by the NSX controller cluster. So with that said, let's take a look at the controller cluster in a little more detail. The controller cluster is really just a series of 3 virtual appliances that are deployed to an ESXi cluster. How are they deployed? Well, an administrator just connects to the vCenter server, opens up the networking and security NSX manager components, and then creates them. So it's not a separate download or anything like that. We simply do it administratively through the vCenter server command center. And these little guys each take up 20 gigs of disk space and should have 4 virtual CPUs with 4 gigs of RAM. A controller cluster node is going to be responsible for a logical switch. Our definition of a logical switch is a VXLAN network ID. So if we create VNI 5002 to be shared by various different VMs on ESXi hosts so they can tunnel to each other and all act like they're on the same exact logical switch, we have a specific controller cluster node that is going to be responsible for that VNI. As we build out multiple logical switches with different VNIs, they'll be handled by other nodes. So what is the brain that NSX controller cluster is really keeping track of? Well, when it comes to switching, there are 3 key tables to be aware of. And those are the VTEP table, the MAC table, and the ARP table. When forwarding frames, we're able to acquire that information from our control cluster nodes, who can provide us the VTEPs, the ESXi endpoints for that particular logical switch. We have a centralized table of the MAC addresses of those VMs and which VTEP those are associated with. And we have a centralized ARP table to keep track of IP to MAC address referencing as well. That's a lot of decoupling of information from the data plane to allow for central processing here at the control plane. Now the control cluster is also responsible for handling distributed routers, just like logical distributed switches. So every ESXi host that's a part of the cluster where a distributed router has been deployed is going to be able to forward packets. However, the IP routing table is not stored on each ESXi host. It's there on a specific node in that controller cluster. Now sometimes that can be confusing because we also have this router control VM, but the router control VM is just a central point of connection for external OSPF and BGP communication in order to be able to route out of our virtualized environment into the physical environment that's already been defined. So really a total of 4 main tables: the VTEP, MAC table, ARP table, and IP routing table. So by having a controller cluster, we can see that we have built-in load balancing, and we also have failover support. If a node in the control cluster should go down, the VNIs that particular cluster was hosting will be assumed by another node in that cluster. VMware's guidance in controller cluster deployment originally suggested that we have an odd number of controller cluster nodes, but that guidance has been replaced by specifically having 3 nodes. And of course, as a best practice, those 3 nodes should be placed on separate ESXi hosts. If we have 3 and we go down to 2, then the failover happens as we just described. But if 2 goes down to 1, then the cluster node will actually shut down. With that said, as we are building up a control cluster, if we create 1 node, it will allow us to start functioning, and that's good for a test environment. But in production, 3 is a magic number. Now, when we create a new VNI using the NSX manager, those instructions are provided to the NSX controller cluster using the REST API protected with SSL encryption. The communication between the ESXi hosts running the logical switches and the controller cluster is performed by benefit of the user world agent and is a secure connection as well. Well, my friend, by going through this nugget together, you've seen how important that controller cluster is to provide the brains the instructions so that our logical switches can forward frames and our distributed routers can forward IP packets. We've got to protect that 3-node son of a gun because it is the heart of our software-defined networking. I hope this has been informative for you, and I'd like to thank you for viewing.